Hello, and welcome to Lesson 10.4 from Big Ideas, Inscribed Angles and Polygons. So we've talked about inscribed angles before when we were talking about a circumcenter and whether things were circumscribed about or inscribed. So in this case, the polygon is inscribed inside of the circle. So what we're going to be talking about today is this with the vertex on the circle, and this is going to be called an inscribed angle. Inscribed angle. So when we have that vertex B is on the circle, and it continues, so we have point A on the circle and point C on the circle. This angle right in here is called an inscribed angle. And then the arc, when it comes out and it meets this arc that is formed right here, is called the intercepted arc. So we would call this arc AC. So angle B intercepts arc AC. Then to read it backwards, we say AC, arc AC subtends angle B. And then we also have a chord that we have been talking about. So this chord with a vertex A and a vertex C, we have this chord, and that chord AC subtends angle B. But the big thing that we're talking about today with the vertex on the circle and its intercepted arc. So inscribed angle and intercepted arc. So we started with, back in 10.1, 10.2, we were talking about a central angle, and the vertex is at the center of the circle. Then this arc, and we would have measured on Geometry Sketchpad, this vertex, the arc, and this vertex, and that measure is 52 degrees. Well, if we take this point and just go back to a point on the circle, and to this point right here, if you look very closely, this angle right here, which is your central angle, and this angle in here do not look congruent. They don't look the same. And so what I would have you do on Geometry Sketchpad is I would have you measure angle A, B, C, and you would find out that the measure of angle A, B, C is 26 degrees. So what would we find out about this inscribed angle compared to its intercepted arc? The inscribed angle is half of its intercepted arc. So here we have the inscribed angle, and so we have angle X, and it's meeting with this arc, 82. And if this were a central angle in here, this central angle would be 82 degrees. Okay, but we are not talking about that inscribed or that central angle. We're actually going to be talking about the inscribed angle, angle X, and that's going to be half of this. And so this X is going to be 41 degrees. Okay, so the inscribed angle is half of the intercepted arc. All right, let's do some 3 quick examples here. So in this first one, the measure of angle X here, this intercepted arc, so we have 35. X is going to be 70 degrees because we're going to multiply by 2. And in the other one, they're giving us the arc and they want us to find the angle. So we're going to divide by 2 and we're going to get 60 degrees. All right, now in the third one, if we have this 100, then we know that this arc right here is going to be how much? Yep, 200. Now, what's the sum of the entire circle? So if we have the entire circle, we're going to set up 200 plus 13x plus 7x, and a whole circle is 360. So if I add these two together and get 20x and subtract 200 from both sides, I get 160. And now if you're going to divide by 20, so these cancel, and x is going to be 8. So I think they just wanted x, so I think we're done. That measure is going to be 8. All right, the next thing here is we have two inscribed angles. We have angle A and angle B. And if you look, this orange right here, this one, the intercepted arc is this bright yellow thing. And if you look at the red B, the intercepted arc is exactly the same thing. So what do you suppose is going to be true about angle A and angle B? All right, yep, they're going to be the same. Those intercepted arcs are going to be the same. All right, so you see angle D and angle C are both going to the same intercepted arc here, and so they are going to be congruent. All right, so in this one right here, this one's a little bit more complicated. So let's see, our ultimate goal is to find angle DEC, which is going to be this angle in here. I'm not sure if you guys can see this, but in here, we're looking for angle DEC. That's our ultimate goal. All right, the first thing I'm going to do is I am going to find angle C. So if we can find out what angle C is, and let me call it ACD to make sure we're all on the same page. So angle ACD has this intercepted arc of 86. So if that is 86, what is the measure of angle ACD? That angle is going to be half of that 86, so we're going to get 43 degrees. Okay, then we're also going to have to do the same thing from this other side and find out if this is 86, if this is 60, then can we find out what this is right here? If this is 60, what's BC? Well, that is going to be 120 degrees. So if that is 120 degrees, then can't we use this inscribed angle, because this green one goes to that intercepted arc of 120. So now isn't the measure of angle BDC going to be 60 degrees? So now within that triangle, can we take 180 minus 60 minus 43, and we're going to be left with this angle that we need of angle DEC, and I think we end up with 77 degrees. All right, using that intercepted arc, might have to pause and go back, but using that intercepted arcs. All right, next one. So we've got a quadrilateral inscribed inside of a polygon. Now, they want us to find out something unique or special with the measure of angle A and the measure of angle C. So it doesn't really matter what number I pick, but I'm just going to pick any number just to kind of prove my point here. And so I'm going to call this to be 100 degrees. If angle A is 100 degrees, what does that leave from this arc all the way over here to B? If that's 100, that inscribed angle, intercepted arc, that's going to leave this arc to be 200. Well, if that's 200, then what is left for this part? Because around the whole thing is 360. So if that's 200 and the whole thing's 360, doesn't that leave this red part to be 160? Now, isn't angle C the intercepted arc to this part right here? So if that arc is 160, what is this inscribed angle? Well, that's going to be half. So this is going to be 80. Now look, what's happening with angle A and angle C. Angle C we found to be 80 degrees, and we started with A being 100. So 100 plus 80 is 180 degrees. Now, could we go through and pick a totally different number? Could I pick angle A to be 88 degrees or 122 degrees? And isn't the exact same thing going to happen? So if you have a polygon inscribed inside, quadrilateral, inscribed inside, those opposite angles are always going to be supplementary. Then its opposite angles are going to be supplementary. All right, in here, because of now we know that those opposite angles are supplementary, then what we can do here is we can take angle A and angle C are going to be supplementary. So, and I'm just going to use x's because my z's just look too much. So I'm going to go 4x minus 10 plus 10 plus 5x, and they have to be equal to 180. They have to be supplementary. So 10 minus 10 is going to cancel out, and I have 9x equals 180. Divide both sides by 9, and I get x to be 20. So now if x is 20, can I find the measure of angle B? So measure of angle B is going to be 6 times 20 minus 5. So I have 120 minus 5. So angle B is 115. And what do we know about angle B plus angle D? We just found out those opposite angles must be supplementary. So take 180 and I subtract that 115 and I am left with 65 degrees for angle D. So angle ADC is going to be 65 degrees. So the two main concepts that we're going over is inscribed polygons. Opposite angles are supplementary, and then inscribed angles, that inscribed angle is half the measure of that intercepted arc. All right, number 42 on your homework today. I'm telling you right now, it's going to be a challenge problem. A hint is for you to go back and look at the geometric mean in lesson 9.3. So you end up with a right angle and then this height coming down. So if you remember, I'm just randomly making up numbers now. These are not part of the problem here. But if you know that that's 12 and this is 7 and you're finding x, remember we did x squared equals 12 times 7. And then if you have to find this side over here, if you recall, it was y squared equals the part that's closest to it times the whole thing, which would be 19. And then you could do the same thing on the other side for finding out what w. Well, that's my hint. And good luck with your homework for today. Again, this lesson was on inscribed angles and polygons.